Imagine spending hundreds of billions of dollars building rockets, training astronauts, creating life support systems, and preparing humanity for the next great leap, all so we can bring a basic electric fan to the moon and turn it on. Honestly, it sounds exactly like something humans would do the moment they get bored on another celestial body. And yes, it also sounds like something Meena would desperately want to test, because curiosity doesn't stop just because you're standing on a dead, gray rock floating in space. But the question is genuinely interesting. What actually happens if you take a normal electric fan, like the one in your living room that squeaks on setting number 3, and turn it on while standing on the moon? Would it blow moon dust around? Would it create the first lunar breeze in the history of the universe? Or would it just sit there rotating like a confused mechanical sunflower? Spoiler, Meena won't reveal the science too early because this is the kind of slow burn nonsense that actually teaches people physics. Let's start at the beginning. The moon has no air. Zero. None. Nada. If you took all the air molecules on the moon and put them in a plastic water bottle, the bottle would still look empty. The moon's atmosphere is so thin, scientists don't call it an atmosphere. They call it an exosphere, which is basically the cosmic equivalent of a single potato chip crumb left in a giant bag after you finish eating everything else. Technically, it exists, but nobody is doing anything meaningful with it. So here you are standing on a world where air does not exist, holding an object designed to manipulate air. It's like bringing a fishing rod to the Sahara Desert. You can do it, but nobody can explain why. A fan works on Earth because it pushes air molecules, trillions of them. Every time a fan blade spins, it grabs air particles and flings them at your face. Those collisions, tiny impacts of gas molecules slamming into your skin, are what you call wind. Wind is not magic. Wind is you being slapped by oxygen and nitrogen over and over again until you feel cooler. Now imagine taking those blades and spinning them in a perfect vacuum. What are they pushing? Nothing. They're just swinging at empty space. It's like trying to shove fog. You look dramatic, but nothing moves. A fan in vacuum is just a fancy spinning sculpture. But Meena knows you want more than that. You want the weird details. You want the scientific flavor sprinkled with sarcastic seasoning. So let's dig deeper. First, the moon's lack of air means there is no drag. None. If you throw something, it keeps going until it hits the ground. If you drop something, it falls in a perfect arc. If you spin a fan blade, the blade doesn't slow down because of air resistance. It only slows down because of friction inside its motor. That means a fan on the moon would actually spin better than on Earth, at least until the motor melts, cracks, freezes, or explodes due to the insane temperatures. Space is not kind to household appliances. Second, electronics behave differently in vacuum. The lubricants inside motors can evaporate. Plastic can become brittle. Metal can crack from temperature shock. If your fan is turned on in direct sunlight, it can reach temperatures over 100 degrees Celsius. If it's in the shade, it can drop below minus 100 degrees Celsius. Your fan is not built for this bipolar behavior. The moon doesn't gently say, "Wow, interesting experiment." The moon says, "Nice fan, shame if something horrible happened to it within 10 seconds. Third, let's talk about moon dust. You might imagine the fan would at least move some dust, right? Dust is light, easy to blow on Earth. But on the moon, dust behaves like a stubborn grandparent. It doesn't move unless you physically disturb it. There is no air to carry dust, no fluid movement, no turbulence. If you want dust to move, you either kick it with your boot, blast it with rocket exhaust, or throw a rock at it. A fan? Forget it. You would have better luck moving dust using telekinesis. Fourth, without air, there is no pressure difference. Wind on Earth is simply air moving from high pressure to low pressure. High pressure cannot exist without air. Low pressure cannot exist without air. You need a fluid to have pressure at all. No air equals no pressure equals no wind. This is like trying to make waves in a swimming pool with no water. The pool exists, but nothing is waving. At this point, your fan is a sad, lonely piece of rotating metal wondering why it came to the moon in the first place. But here's the twist Meena enjoys the most. A fan can work on the moon, but only inside a pressurized lunar base. In a moon habitat, something like an inflatable module or a metal research station, you will have breathable air, temperature control, humidity, and atmospheric pressure similar to Earth. Inside this artificial bubble, your fan becomes fully functional. You could dry clothes with it. You could cool yourself off. You could even recreate that dramatic slow-motion hair in the wind commercial, although your helmet probably would ruin the vibe. But step outside into vacuum, and your fan goes back to being the universe's most useless tool. Now, because this is a fun what-if scenario, let's go even deeper into the absurdity. Suppose a very determined astronaut brings a fan to the moon and insists on making it do something. What could they try? Option 1. Hold the fan really close to the ground. Will that help? No. Dust still won't move because air doesn't exist. Option 2. Spin the fan really fast to create artificial thrust. Nice try. The blades are symmetrical and not shaped for propulsion. They're designed for air, not vacuum. You'd get more thrust by flapping a bag of chips. Option 3. Use the fan as a kinetic tool. You could technically whack moon dust with the blades, turning the fan into the world's saddest shovel. Option 4. Use compressed gas instead of air. Great idea, but now you're not using a fan. You're using a jet, and that's cheating. But don't worry, fans still teach us something extremely important. Earth has invisible systems we rely on without thinking. Air makes fans work. Air makes kites fly. Air lets planes lift. Air lets sound travel. Without it, everything familiar starts acting weird. Fire doesn't burn. Boiling water behaves strangely. Balloons don't inflate. Whistles don't whistle. Hairspray becomes a pointless bottle of sadness. The moon feels like a place where physics forgot to load properly. Another hilarious detail, if you used a fan on the moon to cool yourself off, it wouldn't work. Your sweat wouldn't evaporate normally because evaporation relies on air pressure. You would actually overheat faster because your spacesuit traps heat. Meanwhile, your fan is there spinning its little heart out, trying so hard to help, but physically incapable of doing anything. Let's imagine a commercial. New lunar fan. Guaranteed zero wind, guaranteed zero effect, guaranteed maximum disappointment. Perfect for astronauts who want to question their life choices. Despite all the jokes, the real science behind this is beautiful. The fan experiment reveals the fundamental connection between air, pressure, fluid dynamics, and human survival. It shows that everyday tools only work because Earth provides the environment they need. Strip away that environment, and you strip away half the physics we take for granted. The moon feels like a place where physics forgot to load properly. Another hilarious detail, if you use the fan on the moon to cool yourself off, it wouldn't work. Your sweat wouldn't evaporate normally because evaporation relies on air pressure. You would actually overheat faster because your spacesuit traps heat. Meanwhile, your fan is there spinning its little heart out, trying so hard to help, but physically incapable of doing anything. If you enjoyed this ridiculous but scientifically accurate deep dive into why a fan on the moon is the most useless idea in the solar system, don't forget to like the video, share it with someone who loves space, and subscribe to WiseUse for more fun science explained the Meena way.